Morning. So today we are going to discuss about the linear convolution. So in the last previous classes, we discussed about the properties of discrete Fourier transform. So what are the properties? So we already discussed about the 10 properties: linearity property, frequency shifting, time shifting, Pascal's theorem. Okay, like the time differentiation, circular correlation. Okay, Mm, then circular convolution. So these are the circular frequency shift multiplication property, conjugation property, so time reversal property, periodicity property. All these properties were discussed in our last class. Now we are going to discuss about the linear convolution. What is that? Linear convolution. Linear convolution. So what is meant by linear convolution? By doing this problem, you can understand the concept of the linear convolution. So now determine the response of linear time invariant system whose input x of n and impulse response h of n are given by x of n equal 1 to 0.5, 1. It is started from here, that is x of 0 is 1, x of 1 is 2, x of 2 is 0.5, x of 3 value is 1, and h of n is 1, 2, 1, minus 1. Here h of 0 is 2, h of minus 1 is 1, h of 1 is 1, h of 2 is minus 1. So the response y of n of the system is given by convolution. What is the convolution property? Convolution of the response y of n equal to x of n convoluted with h of n, or we can define in discrete form as k equal to minus infinity infinity x of k into h of n minus k, right? So the input sequence starts at n equal to 0 and the impulse response sequence starts at n equal to minus 1, right? This is a h of minus 1, this is a x of 0, right? So minus 1. Therefore, the output sequence starts at n equal to by adding these two, 0 plus minus 1, that is minus 1. So output sequence y of n will start from minus 1. So the input and impulse response consists of 4 samples. So what is length of the x of n? 4. Here, what is the length of h of n? 4. So L equal to n plus m minus 1. So n is the length of x of n, m is the length of h of n. So the length of these two sequences are 4 plus 4 minus 1. So length of the response, that is L. So output consists of 4 plus 4 minus 1, that is 7 samples, starts from minus 1. So minus 1, 0, minus 1, 0, 1, 2, 3, 4, and 5. So these samples we get as the result. Okay, so here we have several methods are there for finding the linear convolution of the given problem. So method one is a graphical method. First one is graphical method. So the graphical representation of x of n and h of n after replacing n by k are shown as. So here n will be replaced by, for our convenience, small n will be replaced by k. So x of n will become x of k, h of n will become h of k, right? So So x of n, first of all, we will draw the graphical representation of the x of k, that is it starts from 1, 1, 2, it starts from 0, 0, 1, 2, 3, 4. What is the value of x of k at 0? That is x of k value 1. At 1 it is 2. At 3, at 2 it is 0.5. At 3 it is 1. So this is the graphical representation of the input sequence. In the same manner, we can write the graphical representation of the h of impulse response, that is it starts from minus 1 to 2. So at minus 1 its value is 1, at 0 its value is 2, at 1 its value is 1, at 2 its value is minus 1. Okay, from this we have to draw the h of minus k value. It is nothing but reversal of the h of k. So h of minus k. So at minus 1 its value is minus 1. Okay, h of minus k, it is nothing but h of minus k is its a mirror image. Okay, it's a mirror image. So its mirror image is like this. Okay, folded impulse response. So the samples of y of n are computed using the convolution formula, that is y of n is equal to sigma k is minus infinity into x of k into h of n minus k. So x of k value is already given. h of n, we have to find out h of n minus k. Okay, so if n is minus 1, but response will start from minus 1 to 5, right? So if y is minus 1, so for n equal to minus 1, y of minus 1 will become sigma k equal to 0 to infinity x of k into h of minus 1 minus k, right? Minus 1 minus k. So when n equal to minus 1, y of minus 1 is x of k into h of minus 1 minus k. Okay, so x of k is this one, h of minus 1 minus k is this one. H of minus, already h of minus k value is there. So minus 1 minus k is represented like this, minus 1 minus k. And by straightforward method, minus 1 minus k minus 2, minus 1 minus k equal to minus 2, then minus k equal to minus 1 or k equal to 1. At 1 its value is minus 1 minus k equal to minus 2 or minus k 1. Right, like this, so we can find out the these values, and by simply multiplying these two values we will get the result y of minus 1. So minus 2 value is minus 1 and minus 6 value is 0. So minus 1 into 0, 0 plus like this. So like this, y of minus 1 will get 1 value. Similarly, when n equal to 0, y of 0 will become 0 minus k, that is h of minus k. H of minus k function is already there. So by simply substituting these two functions, we can get the resultant like this. If y equal to 1, so 1 minus k, this is 1 minus k, right? So 1 minus k, where the 1 minus k graphical representation. So this is h of 1 minus k and this is x of k. By simply multiplying these two, we will get y of 1 equal to 5.5. Similarly, when n equal to 2, like this up to n equal to 5, we will calculate. For n equal to 2, y of 2 will become sigma k equal to minus infinity into x of k to h of 2 minus k. So this is h of 2 minus k and this is x of k. By simply multiplying these two, we will get y of 2 value is 3 like this. Okay. Next, if n equal to 3, then it will become h of 3 minus k. Okay, 3 minus k, x of k into h of 3 minus k. So this and this, multiply these two, we will get the result like this. Okay, that is 0.5, y of 3, 0.5. If y is 4, then sigma k equal to minus infinity into x of k into h of 4 minus k. So h of 4 minus k is this one, and x of k is this one. By simply multiplying these two, we will get y of 4 like this. So its value is 0.5. And finally, y of 5. So y of 5 equals sigma k equals 0 to infinity this one. H of 5 minus k is this function, and this is x of k. By simply multiplying these two, we will get y of 5 value is minus 1 and graphical representation is this one. Okay. So finally, we can write the output sequence as y of n equal to 1, 4, 5.5, 3, 0.5, 0.5, and minus 1. Okay. So starts from minus 1 to 5. Minus 1, 0, 1, 2, 3, 4, 5. It starts from minus 1. So this is 0. At 0 its value is 4. At minus 1 its value is 1. At 1 its value is 5.5. At 2 its value is 3. Okay. At 2 its value is 3. At 3 its value is 0.5. At 4 its value is 0.5. At 5 its value is minus 1. Like this, we can draw the, or we can do the linear convolution linear convolution of the x of n and h of n, so that we will get the response y of n like this. This is one method. And another method is there, that is tabular method. Okay? Tabular method. So by using the graphical representation, from the graphical representation we can have the values. So write those values in this table. Write those values in this table. So k minus 3 minus 2 minus 1 0 1 2 3 4 5 6. Okay. So x of k is given like this. X of 0 value is 1. X of 1 value is 2. X of 2 value is 0.5. X of 3 value is 1. Similarly, h of k value starts from minus 1. Okay. H of minus 1 is 1. H of 0 is 2. H of 1 is 1. And h of 2 is minus 1. Right? Now h of minus 1 minus k values are starts from minus 3 to 0. So h of minus 1 minus k of minus 3 starts from minus 3 to 0. Similarly, h of minus k starts from minus 2 to 1. H of 1 minus k starts from minus 1 to 2. H of 2 minus k starts from minus 1 to 3. H of 3 minus k starts from 1 to 4. H of 4 minus k starts from minus 1 to 5. And h of 5 minus k starts from minus 1 to 1. Like this, we can write these values in this tabular method. So this is a tabular method. So we can take these values from the above graphical representation. Okay, above graphical representation. This is one method of finding the linear convolution. And the next method is matrix method. Okay, matrix method. So in matrix method, we can take the x of n value and h of n values like this. X of n values are given 1, 2.5 and 1, and h of n values are 1, 2, 1 and minus 1. So by simply multiplying these two, so 1 into 1, 1, 1 into 2, 2, 1 into 1, 1, next 1 into minus 1, minus 1, right? So 2 into 1, 1, 2 into 2, 4, 2 into 1, 2, 2 into minus 1, minus 1, like this. Next 0.5 into 1, 0.5, 0.5 into 2, 1, 0.5 into 1, 0.5, 0.5 into minus 1, minus 0.5, like this. Next 1 into 1, 1, 1 into 2, 2, 1 into 1, again 1, 1 into minus 1, minus 1. So these are the values after multiplying this x of n and h of n. Now taking the diagonal values. Diagonally we'll draw the dotted lines here. So this diagonal value, this is 1. This value is nothing but y of minus 1. It starts from minus 1 to 5. The response y of n, which starts from minus 1 to 5. So this first value is y of minus 1 value, that is 1. And the second diagonal value is 2 plus 2. So this is y of 0 value. Y of 0 value is 2 plus 2. And by adding these three values, we will get the y of 3 values 0.5 plus 4 plus 1, 5.5. This is y of 1 value. And by adding these four values, we will get the y of 2 value 1 plus 1 plus 2 plus minus 1. That is 4 minus 1, 3. Next, by adding these three values, 2 plus 0.5 plus minus 2, that is 0.5. That is y of 3 value. By adding these two values, 1 minus 0.5, that is 0.5. This is y of 3, 0.5, that is y of 4 value. And this minus 1 is nothing but y of 5 value. By taking all these values as a set, so y of n is equal to 1, 4, 5.5, 3.5, 0.5, and minus 1. This is the output response. Like this, we have the three methods of finding the linear convolution. First one is graphical method, second one is tabular method, and third one is matrix method. In any method, we can do the linear convolution. Okay, linear convolution. Like this, we have three methods. So is it clear? Next we'll go for the next one. That is filtering long duration sequences. This is called sectioned convolution. Filtering long duration sequences. Filtering long duration sequences. So this is called section convolution. The response of LTI system for an arbitrary input is given by a linear convolution of the input and the impulse response of the system. As we already know that the response is nothing but x of t convolved with h of t, or x of n convolved with h of n, that is nothing but a sigma k equal to minus infinity into x of k into h of n minus k. As we already done a problem also based on this formula. Okay, if one of the sequences, either the input sequence or impulse response sequence, is very much larger than the other one, then it is very difficult to compute the linear convolution for the following reasons. So if these two sequences are equal, then we can easily do the linear convolution. If one sequence is larger than the another one, then the linear convolution will become a little bit difficult because of the following reasons. What are those following reasons? First reason is the entire sequence should be available before convolution can be carried out. The entire sequence will be available before convolution can be carried out. This makes long delay in getting the output. So it will take long delay. After that, second reason is large amounts of memory is required to store the sequences. The above problems can be overcome in the sectioned convolution. So these are the two problems. First one is the entire sequence should be available before convolution can be carried out. So this may take a long delay, and a large amounts of memory is required to store the sequences. So these two problems can be solved or overcome by using the sectioned convolution. So there are two methods of sectioned convolutions are there. Those are overlap add method, and overlap save method. So in our section convolution, we have two methods are there. Those are overlap add method and overlap save method. What is overlap add method and what is overlap save method? See the overlap add method. In this method, the longer sequence is divided into smaller sequences. So one of the sequence may be longer than the other one. So take the longer sequence, it will be divided into smaller sequences. This linear convolution of each section of longer sequence and smaller sequences is performed. The overall output sequence is obtained by combining the output of the section convolution. So this longer sequence will be divided into smaller sequences. After that, we will do the linear convolution with individual sequences and add the resultant. Okay, so that is overlap add method. Let n1 be the length of the longer sequence, n2 be the length of the smaller sequence. Let the longer sequence will be divided into sections of size n0 samples, right? So here important point we have to remember is normally the longer sequence is divided into sections of size same as that of the smaller sequence. Smaller sequence size, based on the smaller sequence size, we will divide the longer sequences. Okay, so that is n3 plus n2 minus 1. Okay, so n3, if we take n3, n2 minus 1, this is smaller sequence, this is larger sequence. So here if we take, this is n2 minus 1, n3 minus n2 minus 1, this is n2 minus 1. So this is n3 plus n2 minus 1. This is overlap region. Okay, this is also overlap region. Okay, so this is n3 plus n2 minus 1. Like the overlap regions are there. So we are adding these overlap add method. Samples in the shaded region are added. So here n2 minus 1, n2 minus these two are added. These n2 minus 1, n2 minus 1 added. Okay, so that we will get n3 plus n2 minus 1. Here also n3 plus n2 minus 1. Here also n3 plus n2 minus 1. So by adding these two, we will get n3 plus n2 minus 1. By adding these two, we will get n3 plus n2 minus 1. Here these are overlapped here. These two are overlapped here. Right? So the shaded regions are added. Overlapping of output sequence of overlap add method. So the linear convolution of each section with a smaller sequence will produce an output sequence of size n3 plus n2 minus 1 samples, n3 plus n2 minus 1 samples. In this method, the last n2 minus 1 sample of each output sequence overlaps with the first n2 minus 1 n2 minus 1 samples of the next section. That is, there will be a region of n2 minus 1 samples over which the output sequence of qth convolution overlaps the output sequence of q plus 1 convolution. While combining the output sequence of the various section convolutions, the corresponding samples of overlapped regions are added and the samples of non-overlapped regions are retained. Okay, so this is the overlap add method. So same sequences are overlapped here. So here we have three sections. So in these three sections, n2 minus 1 is common. So these two are overlapped. These two are overlapped. Right? These are added. So shaded region are added. This is called overlap region. Over the region. Okay. So this is over. This is called overlap add method. Next, overlap save method. Coming to the overlap save method. In this method, the results of linear convolution of the various sections are obtained using circular convolution. Here, the results of the linear convolution of the various sections are obtained using circular convolution. In this method, longer sequence is divided into smaller sequences. Each section of longer sequence and smaller sequence are converted to the size of the output sequence of sectioned convolution. So the circular convolution of each section of the longer sequence and the smaller sequence is performed. The overall output sequence is obtained by combining the outputs of the sectioned convolution. Let n1 be the length of the longer sequence, n2 be the length of the smaller sequence. Longer sequence will be divided into sections of size of n0 samples. Normally, the longer sequence is divided into sections of size same as that of the smaller sequence like the above one. In this overlap save method, the result of linear combinations are obtained by circular convolution. Okay, hence each section of longer sequence and the smaller sequence are converted to the size of output sequence of size n3 plus n2 minus 1 samples. The smaller sequence is converted to size of n3 plus n2 minus 1 samples by appending with zeros. By appending with zeros. The conversion of each section of longer sequence to the size n3 plus n2 minus 1 samples can be performed into two different methods here. Overlap saving method will be performed in two different methods, method 1 and method 2. Two methods are there. Okay, so those are method 1. Method 1. In this method, the first n2 minus 1 samples of the section is appended as last n2 minus 1 samples of the previous section, that is, overlapping samples are placed at the beginning of the section. The circular convolution of each section will produce an output sequence of size n3 plus n2 minus 1 samples. In this output, the first n2 minus 1 samples are discarded and the remaining samples of the output of section convolutions are saved as the overall output sequence. See, this is appended. n2 minus 1 is appended to n3. That is n3 plus n2 minus 1. Okay. The next section n2 minus n1, n2 minus n1, n3 minus n2 minus n1 is there. So here these two are overlapped. So similarly, this is n3 minus n2 minus 1 and this is n2 minus 1. These two are overlapped and appended with the zeros. This is appending of sections of input sequence in method 1 of overlap save method. Okay. Appending of sections of input sequence in method 1 of overlap save method. Here the zeros will be appended here in this method. Okay. So this is n2 minus n1, n3 minus n2. This is n2 minus n1. Okay. So n2 minus n1, n3 minus n2, n2 minus n1. So this is overlap region. Then this is n2 minus n1 into n3 overlap of n2 minus 1 regions. Okay. This is n3 plus n2 minus 1. This is also n3 plus n2 minus 1. Samples in the shaded regions are discarded. Samples in the shaded regions are discarded here. So this is overlapping of output sequence of section convolution by method 1 of overlap save method. So by doing the one or two problems, we can understand this concept. So we can do the problem. Perform the linear convolution of the following sequences by overlap add method and overlap save method. So here x of n is a longer sequence than the h of n. X of n is given as 1, minus 1, 2, minus 2, 3, minus 3, 4, and minus 4. And h of n is given as minus 1 and 1. Okay. So by doing this by using these two methods, we can solve the linear convolution of the given sequence. Okay. So first one is overlap add method. In this method, the larger sequence is section into sequence of the size equal to smaller sequence. Okay, here x of n is a longer sequence when compared to h of n. Hence, h of n is section into sequences of x of n is section into sequence of size of h of n. Right, h of n size is 2. Okay, x of n size is 8 numbers are 1, 2, 3, 4, 5, 6, 7, 8. So we can divide x of n into 4 sections. Why? Because the size of h of n is 2. Okay, given x of n is 1, minus 1, 2, minus 2, 3, minus 3, 4, minus 4, and x of n can be sectioned into 4 sequences, each consisting of 2 samples of x of n. So first section consists of x of n is 1, minus 1. N equal for n equal to 0, it is 1, n is 1, it is minus 1. For section 2, x2 of n is equal to 2 minus 2. N is 2. For 2 and 3, it is 2 minus 2. Section 3, for 4 and 5, it is 3 and minus 3. Okay. And for section 4, for 6 and 7, it is 4 and minus 4. Let y1 of n, y2 of n, y3 of n, y4 of n be the output of the linear convolution of the x1 of n, x2 of n, x3 of n, and x4 of n with h of n. So here h of n starts at n equal to 0, right? H of n starts at n equal to h of 0. It is also starts at x of n equal to 0, right? x1 starts at n equal to n1 equal to 0. So y1 of n will start at n equal to n1 plus n2, n1 plus n2, that is 0 plus 0, that is 0. Okay. Similarly, x2 of 1 starts at n equal to n2 equal to 2. 2. Similarly, y2 of n starts at n equal to n2 equal to 0. So 2 plus 0, 2. Similarly, x3 of n 4. It starts at 4 plus 0, 4. It starts at 6. So 6 plus 0, 6. Like this. 4 sections will start at these points. So 0, 2, 4, and 6. So here linear convolution of each section is performed between 2 sequences, each consisting of 2 samples. Hence, each convolution output will consist of 2 n3 plus n2 minus 1. That is n3 is 2. N2 is also 2. 2 plus 2, 4, minus 1, that is 3 samples. So here N1 is 8, and N2 is 2. So N3 is 2. Okay. So N2 minus 1 is 2 minus 1, that is 1. N3 plus N2 minus 1, that is n3 is 3, n3 is 2 plus n2 minus 1 is 1, 2 plus 1, that is 3. Okay. So the unfilled boxes in the tables are considered as 0. For convenience, index n is sampled by k. So n is replaced by k. So k 0, 1, 2. So x1 of k it starts from 0, 0 to 1 minus 1. Which of k is minus 1, 1. Which of minus k, 1 minus 1. Which of 1 minus k is this one. Which of 2 minus k is this one. Like this. y1 of n is x1 of n converted to h of n. So y1 of n equal to x of k, h of n minus k. Okay. When n equal to 0, this is minus k, h of minus k. So x of k into h of k. So these two values, x of 0 into h of minus k values minus 1. X of 0 into x of 0, that is 0, 0 into 1, 1 into minus 1 plus minus 1 into 0. So it is minus 1. Similarly, y1 of k. X of k value is 1. And 1 into 1 plus minus 1 into minus 1. Like this, you can find those values. And n equal to 2, it is minus 1. And n equal to the same manner convolution of section 2. Section 2 we can find out. Or by using multiplication method also we can find out these values. Okay. For like this, for all sections we can find out these values. And after finding the 4 sections, we can add those values. So it's can convert with h of n minus 1, 2, minus 3, like this, y of 0 to y of 8 values. Okay. This is overlap add method. So do it individually so that we can understand this problem. So finally, we can find linear convolution of the sequence x of n and h of n is minus 1, 2, minus 3, 4, minus 5, 6, minus 7, 8, and minus 4. Right? So in the next class, we will see the overlap save method. So by doing this problem, we can understand the overlap add method. Okay, overlap add method. This I am concluding this class. Tomorrow we will see the overlap save method.